What do you think about a piece of Java code that takes an object but returns nothing? Sounds a bit like the programming equivalent of a black hole. That is pretty much what consumers are in Java. Let me explain what I mean by taking a look at consumers in detail in this video. By the way, I'm Saeed, the Codogrammer, and if you don't want to be the last to know about industry news, tech tutorials, and more, then make sure you consume that subscribe button. Now, before we continue, would you like to hear a joke about Java consumers? No? Well, I'm going to tell you one anyway. Why did the Java consumer go to the coffee shop? To consume a bunch of Java beans. Okay, that was a terrible joke, I know. But in my defense, I didn't come up with that joke. That joke was generated by ChatGPT. And let me know if you can do any better in the comments below. All right, so here I am in a Java project in IntelliJ. Now, a consumer is a functional interface. It's annotated with the @functional interface annotation. It lives inside the Java util function package. We'll take a look at that in a second. That's the go-to place for Java functional interfaces if you want to explore. Now, let's have a look at the declaration. So I'll just click into there. And you can see there, as I mentioned, it's a functional interface. It lives inside the Java util function package. We'll click into there in a second and have a look. Now it has one abstract method. It doesn't need to mention that it's abstract because this is an interface. So by definition, that is abstract, which is an accept method that accepts a generic type T. So whatever type you declare for the consumer, that's the type of value that you pass into the accept method, which is as yet unimplemented. It's an abstract method. That's why you don't see any curly braces or body here. And then we have one default method. Now this is just an implemented method. Don't worry about the default keyword if you don't know what that means at this point. It's just a method available on this interface that's got its own implementation. So it's like a utility method. And we'll have a look at what that does shortly too. So going back to our class, you can see an example of a consumer here. Now this consumer takes a string. It's called print. And all it does is it prints out that value. Now, if you look here, this is implemented as a method reference. You know it's a method reference because we've got this double colon thing going on here. The alternative would be a lambda, like you can see here. In fact, let's create that alternative here. We'll call that print2, and I can literally just paste this because it's the same thing. All right, so these two are equivalent. This is a method reference and this is a lambda implementation. I'll go through a bit more about what that means shortly. All right, so consumers being a functional interface means that implementations of the functional interface can be passed around the way you would normally pass a variable around. In other words, you can pass a consumer, a piece of code, to a method just like you would pass a value like somebody's age or somebody's name. Now, here we've got an example, a method called useConsumer. In here, we've got a method, well, we call a method, so let's click into there. We call the consumer method. Now this method declares two parameters, and the first one is a consumer of type string. That's a generic type there. And the second one is the string value. Now inside that method, it executes the consumer. Remember that abstract accept method, and it passes the value s, which is the other parameter here. Now you might be thinking, well, where's the actual implementation? This is an abstract method, and you're thinking correctly. We need an implementation for this functional interface, and that implementation is in the form of this lambda here. This lambda says, hey, my implementation of this consumer is where we say s goes to system.out.println s, which simply prints out hello. And the alternative to that, which is basically the same thing, but we just don't have to mention this parameter here, you can just do it behind the scenes. So this type here is called a lambda, and this type here is called a method reference. In both cases, we pass it hello, and we call the run consumer method, we pass it the implementation of the consumer and a value. Now let's just run that and see what happens. Okay, and in both cases, it printed out hello. So we called run consumer once and we asked it to print out hello, and it did that. We called run consumer again using the method reference and it printed out hello. All right, so let's move on to the next class. So just before we continue, I'm just going to show you a typical use case for a consumer, which is to print elements of a list. So here we have a list with 3 elements inside it, A, B, and C, 3 strings, and we call the for each method. Now, if I look at the for each method, it takes a consumer of type T, and the type T in this case is the elements in the list. So that means that we have to pass it a consumer, which can take a string. Now, system.out.println can print a string. So let's just run that and see what happens. All right, and so you can see it printed out each element of the collection. Now in this case, it's got 3 elements. It could have 1,000 elements, it doesn't matter. For each one of them, it will call this consumer implementation, which is done via a method reference in this case. But having said all of that, consumers are a bit weird. They take a value, but they don't return anything, a bit like a black hole, as I mentioned in the introduction. Now we've got an example here. This is not a good consumer implementation in most cases, but I'm just going to show you what I mean here. You've got a consumer here, which takes a string and does literally nothing with it. It's just got an empty set of curly braces. So it pretty much ignores the parameter. Now, aside from this quirky implementation where we don't really do anything with the value, the key thing to remember is that a consumer usually does something with the value that is passed. So let's have a look at a couple of examples examples here. So we've got the first consumer called DB. Now this is of type string, and what it does is it inserts that string into a database. It doesn't actually, we've just got a dummy method here that doesn't do anything, but just for the purposes of demonstration. So this one takes every value that's passed to it and it inserts it into a database. This one here is another example where we have an email consumer, and this one, every value that you pass it, it emails it to a customer. What's the customer's email address? What's the value of the string? We don't know any of those things. It's just for demonstration purposes. So you see a couple of examples here where it takes a value and it does something with that value. Now these consumers are going off and doing something but not returning a value. So what does that mean? Well, this is referred to in programming as side effects, where a function does something but doesn't return a value. Now side effecting functions have a bit of a bad name in programming, especially if you come from a functional programming background. Such functions, like these consumers, are said to be impure, and they make the code harder to reason about because they are tricky to test, difficult to debug. You don't immediately see the result of what you've executed coming out of the function. However, the reality is that in real world useful programs, side effects are inevitable. So things like I/O, logging, interacting with users, writing to databases, that kind of thing, all very, very important critical functions of most programs. They're all considered to be side effects. And the key thing to remember is that Java is not a purely functional language. It allows both object-oriented programming and functional programming to be combined. And in my opinion, its real strength is when you combine the two. It's a practical language, so you'll find cases where you will want to use a consumer, and in Java you can do so without shame. All right, so you might recall earlier that when we looked at consumer, there was an and then method. So I'm just going to click onto here and just show you that again. We've got this and then method, which takes a consumer and returns a consumer. Okay, so it looks a bit strange, but what this essentially allows you to do is to combine consumers, where you want a value to be consumed by one consumer and then consumed by another consumer. So we've got an example here where we have a print uppercase consumer, which takes the string and prints it in uppercase. Then we have another consumer, which prints it in lowercase. So they're very similar. One does uppercase, one does lowercase, and both of them print the value that's passed to them. We can combine them by saying print uppercase, which is the first one, and we can say and then and pass it another consumer. We pass it the print lowercase consumer, and then we call the except method, which executes the resulting consumer. Now you take this consumer, call the and then method, and this returns a new consumer, which is effectively going to execute both things. All right. And then we call the hello world function. So let's just comment this out for a second and just run this and see what happens. All right, so you can see it printed out hello world in uppercase, then it printed out hello world in lowercase, and we didn't have to call those consumers separately. We call the and then method, and the resulting consumer will execute both. So I'll just uncomment this. And here we have an example where we then print the length of the string. So we generate another consumer here. And in this example, we print uppercase, then we combine it with print lowercase, and then we call the and then method, because remember, this returns a consumer as well. Okay, so this is a consumer, combining it with another consumer returns a consumer. And that also has the and then method. So we can combine it with yet another consumer and then pass it hello world. All right, so let's run this and see what happens. Okay, this is the output from the existing code that we had, and this is the output from the new code. And if you look here, we just called the except method on the consumer once, but it executed all three consumers effectively. The first one uppercase, the second one lowercase, and the last one printing out the length. All right, so hopefully that makes the and then methods usage nice and clear. All right, so now you understand a bit about consumers in Java. I'm going to make it slightly more complex by introducing something called a by consumer. So what on earth is a by consumer? Well, it's actually not so complex. In the examples we've seen, remember we pass a single value to the consumer to process. In most of the cases, I think in almost all the cases, we pass a string to the consumer. But what if we want to pass two values, two strings, or an integer and a string, or whatever? Well, we can do that with something called a by consumer, slight misspelling there. And let's take a look at a couple of examples. So in this case, we have a by consumer, which is just like a consumer, but it takes two values. Okay, and it's called multiply. So it basically takes these two values and prints out the result. So it multiplies them and then prints out the result. And we can pass it like 5 and 7. So if I just comment this out and run the main method, all right, you can see that we get the result, which is 35. So I'll just comment that out. And now here we have another example where we concatenate the two values. So let's just run that and see what happens. All right, and it didn't actually concatenate them. It added them together because it's an operation on integers, not strings. Okay, so if these were strings, it would have concatenated them. So you would have got 5 and 7 next to each other, sent 57. But instead of that, because they are integers, it just this plus symbol will just add the numbers together and print out the resulting value. So you can see how a by consumer can be useful if you have two parameters instead of one. All right, so now that we can handle things where we have one parameter and where we have two parameters, well, what if we have more than two? What if we have 3, 4, 5 parameters? Well, in that case, if you really must generate a consumer for that, and I'd consider whether a consumer is right in that scenario, you don't really want to have these very long lists of parameters to consumers. But say for argument's sake, you want to do, it's very easy to declare your own functional interface. So all you do is declare an interface. You wouldn't usually do it inside a method like I've done it here for demo purposes. You'd declare it at the top level, and we call it try consumer. It declares 3 different types, and these different types are the types of the parameters to the accept method. And then here we have an actual implementation where we multiply these 3 numbers together. And if we want to actually execute this, we can say multiply.accept 5, 7, and 9. And let's just comment this out and uncomment that and run it and see what happens. All right, so we get 315. I'm assuming that that is correct. And so now you can see that you can generate try consumers. You could have a consumer that takes 4 parameters, 5 parameters, 6 parameters. But I think carefully before creating those kinds of interfaces to see whether it actually makes good design sense. All right, so that's pretty much covered what I wanted to cover about consumers today. I hope that made sense. As always, let me know in the comments below if this information was useful and if you have any questions. And also let me know if I missed anything. Okay, so if you are the curious type, then check out this video where I go through the differences between functions, suppliers, and consumers in Java. Thank you for watching.